Now we're going to look at a couple other special angles, 30 degrees and 60 degrees, and we're going to compute the trig functions for those angles by hand. There are very few angles where we can do this. So we already looked at 45 degrees, now we're looking at 30 and 60, and that's pretty much going to be it for the angles whose trig functions we can calculate just by using basic geometry. And we're going to do 30 and 60 together in this one exercise. And to get started here, I'm going to take a very simple shape again to get started. I have a triangle where all three sides are equal. This is an equilateral triangle. And I think you probably know that when all three sides of a triangle are equal, all angles are equal. And since the angles have to add up to 180, and they have to be equal, 180 divided by 3 is 60. So each angle of an equilateral triangle is 60 degrees, right? Now, what we're going to do is we can't apply SOHCAHTOA to an equilateral triangle because it's not a right triangle. So we're going to fold along an altitude or height, you could say, of that triangle. We're going to fold it in half, and we're going to look at the triangle that we end up with, and that's called a 30, 60, 90 right triangle because one of the 60-degree angles got folded in half. So let's go ahead and draw some pictures of what's going on here. So we're starting out with an equilateral triangle where each angle is 60 degrees. And each side has the same length. It can be large or small as far as the trig function values are concerned. So I'm going to pick 1 for my sides again. I could set this to be any number like 222, 888. It would come out to be the same result. And then we're going to fold it in half. And when I fold in half, now the angle right here is 90 degrees at the fold. This 60-degree angle stays the same, but now up at the top I've folded a 60 in half, so I have 30 degrees, right? And let's see, this side is still 1, but this side along the bottom is going to be 1/2 because it's only half of one of those 1 unit sides. And here we gotta find how long this height is. We're going to use the Pythagorean theorem. I'll just label that x. I don't want to use c. It's not the hypotenuse now. It's one of the legs of the right triangle, one of the sides of the right angle. So to apply the Pythagorean theorem, I have to say x squared plus 1/2 squared equals hypotenuse squared. That's 1 squared. X squared plus 1/4 equals 1. So x squared is 1 minus 1/4. That's 3/4. And now I can take square roots. And once again, it's got to be positive. And so I only need the positive root. I'm looking for a length. And I can take square roots in numerator and denominator separately. So I get square root of 3 over square root of 4 is 2. So x is square root of 3 over 2. Okay. And now we're ready to use SOHCAHTOA. So once more, I want to advertise my little yellow card that I think has really important information on it to memorize. We're going to start with maybe 30 degrees. Sine of 30 degrees is opposite over hypotenuse, but now opposite from the 30-degree perspective. So I'm going up to this triangle. Opposite to 30 degrees is the 1/2 side. The hypotenuse is 1. 1/2 over 1. Anything over 1 is itself, so that's 1/2. And I know the decimal for that. That's 0.5. Of course, you don't have to write the decimal, but sine of 30 degrees is a half. Cosine of 30 degrees is adjacent over hypotenuse. So for the 30 degree side, now remember 1 is the hypotenuse, so the other side is the adjacent side to 30 degrees. That's square root of 3 over 2. So over 1. And I can just write that as square root of 3 over 2. That's the cosine of 30 degrees. And make sure you don't have any trouble getting the calculator value for that. That's about 0.8660, I think. Rounded off at 4 places. And now tangent of 30 degrees. TOA is opposite over adjacent. So it's a little bit messy here, right? Because the opposite side is a half. The adjacent side is square root of 3 over 2. So I have a fraction division problem here. And this is fine if you can do it in your head, but I'm just going to write this out in case anybody likes to. Now when I write it, if you need to write it out, just take your time. It's the fraction on top divided by the fraction on the bottom. You leave the first fraction alone and you multiply by the reciprocal of the second. The square root of 2 cancels. We have 1 over the square root of 3. And I'm perfectly happy with that answer. But if you want to rationalize, you'll get square root of 3 over 3, which is equivalent, same number, different look. And the decimal I get is 0.5774. So there we have the sine, the cosine, the tangent of 30 degrees. And now we got to do 60 degrees. Still SOHCAHTOA. But now when we think of the 60 degree angle, right here, its opposite side, opposite to 60 degrees, is square root of 3 over 2. Hypotenuse is still 1. So square root of 3 over 2 over 1, or square root of 3 over 2, is the sine of 60 degrees. It's the same as the cosine of 30 degrees, right? But not the same as the sine of 30 degrees. The cosine of 60, you can probably guess what that is already, but we'll just go ahead and work it out. Adjacent over hypotenuse for 60 degrees. The adjacent side is the 1/2 side. Hypotenuse is 1, so that's 1/2. Same as the sine of 30 degrees, right? And tangent of 60 degrees is opposite over adjacent. So let's see, for 60 degrees, that's square root of 3 over 2 over 1/2. And again, I gotta divide that out. And notice here it's the 1/2 whose reciprocal I have to take. 2's cancel. I get square root of 3 over 1, which is just square root of 3, is the tangent of 60 degrees. The decimal for that is about 1.7321. Calculator value. So there we got sine, cosine, tangent of 30 degrees and 60 degrees by hand.